the correlation coefficient on our calculator. So we can use the formula as shown in chapter 4 of your text. If you take a look at the textbook, there's quite a few pages devoted to using that formula and getting the R value manually. If you want, you can take a look at that. If we use a function called linreg, which stands for linear regression, on our calculator, we can get the same value for R. Okay, there is a calculator setting that we have to turn on. It's called diagnostic on. And when we do this, we'll never have to do it again unless our calculator is reset. But it's important that we turn diagnostic on now, otherwise we won't be able to find the R value. So we're going to go to second, catalog. It's the blue letters above the 0 key. Okay, this is a catalog of all calculator functions in alphabetical order. If we press, let's see, notice that there's an A in the upper right corner. It means we're in alpha mode, which means that any green letter above these keys, if we press a key, it's going to go to that letter. So I'm going to go to the key that says x to the negative 1, because there's a D above it. Okay, so I'm now in the D's. I want to go down to diagnostic on. So scroll your cursor downward. Okay, there's diagnostic off and diagnostic on. So highlighting diagnostic on, hit enter. With it on your home screen, hit enter again, and it's done. Okay, once the diagnostic is on the calculator, there's no need to redo this step. It'll stay like that until you run out of batteries and have to reset your calculator. So once it's done, it's done. Okay. Use the sample data in the calculator to calculate the sample correlation coefficient R. Okay, we already put this data in our calculator. So what we're going to do to find out R, we're going to use a calculator function called linear regression. It's the number 4 item in the menu under Stat Calc. So we're going to press Stat. We're going to go over to the Calc menu. This should be familiar because this is where we specify, this is where we find the standard deviation using one variable statistics. We hit enter, but first, before we hit enter, we have to scroll down to number 4, linreg ax plus b. Don't make the mistake of accidentally choosing, there's another one down here, linreg a plus bx, which is number 8. They'll give you different answers. So make sure you highlight 4, linreg ax plus b, hit enter. Okay, we're asked for an X list, a Y list, frequency list, store reg EQ, and calculate. Okay, so in X list, we're going to identify the list where our X values are, which for me is L1, so I could just leave that as it is. In Y list, we identify the list where our Y values are, which is L2, so leave it as is. Frequency list, leave it blank. If all your data is in L1, L2, there's no reason to have any number here for frequency list. We're going to store regression equation, that's REGEQ, that's what it stands for, regression equation. We'll leave that blank for the time being, and we're going to go down to calculate. So the only things that we're really setting here are L1 and L2. And then we hit enter. Okay. Here's our output. We have a value for A, a value for B, which we will talk about at our next lecture, a value for R squared, and a value for R, Now we said before that Pearson's correlation coefficient is defined by the letter R. So our correlation coefficient is negative 0.96923, etc. We are going to round our correlation coefficient to 2 decimal places, which makes it negative 0.97. That is a strong negative linear correlation. Okay, strong negative linear correlation, negative 0.97. Okay, let's remember that the correlation coefficient is any number between negative 1 and 1, and it represents how strong a linear correlation the two variables have. So the fact that our correlation is negative, the fact that it's coming out as negative here should also match the fact that we saw it negative when we produced the scatter diagram. It was the points were moving downward from left to right. The closer the number is to 1, the stronger the positive linear relationship, and the closer it is to negative 1, the stronger the negative linear relationship. So what we have here is a strong negative linear relationship. R is approximately negative 0.97. It's very close to negative 1, and so it represents a strong negative linear relationship. Okay, we're